A 75 kVA transformer can supply up to two 225 amp 42 circuit panel boards. The second and third set of derived secondary conductors should originate at zone X2, X3 and X0. Each set of derived secondary conductors should terminate on a separate 225 amp main breaker in each of the 3 panel boards. Regarding computer with conductor identification, the number 12 black, red, and light red wires are the phase conductors A, B, and C. The number 12 blue wire is the isolated ground. One number 12 white wire is the equipment grounding conductor. Another number 12 white wire is the neutral conductor. The number 12 green and green wires are the grounding conductors. The additional white and light red wires are typically not used in a standard 3-phase power system, so investigate their purpose. Here proposed field quieting techniques are generally sound. In addition to isolating one green from all but the X0 via an isolated terminal bar in the panel board, bonding the building steel with a number 2 wire, and upsizing the white wire to number 10, consider the following suggestions to quiet the fields further. Firstly, use shielded cables for critical equipment to minimize electromagnetic interference. Secondly, implement load balancing to distribute the load evenly across all 3 phases. Thirdly, consider installing a harmonic filter to mitigate harmonic currents. Regarding spell check, you can use firstly the browser's built-in spell checker, usually activated by right-clicking, or secondly, a dedicated spell checking tool, such as Grammarly or Microsoft Word. Ensuring proper grounding is crucial for safety and minimizing electrical noise. The equipment grounding conductor, often a bearer or green wire, provides a low impedance path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. The neutral conductor, typically white, carries the unbalanced current in a 3-phase system back to the source. Proper sizing and installation of grounding and neutral conductors are essential for a safe and reliable electrical system. Remember to consult the National Electrical Code, or NEC, and local electrical codes for specific requirements and guidelines. Harmonic currents can cause overheating of transformers and other electrical equipment, leading to premature failure. Harmonic filters can be installed to reduce harmonic currents and improve power quality. Load balancing involves distributing the electrical load evenly across all 3 phases of a 3-phase system. This helps to minimize neutral current and reduce voltage imbalances. Shielded cables can help to reduce electromagnetic interference, or EMI, which can disrupt the operation of sensitive electronic equipment. It is important to properly terminate the shields of shielded cables to ensure effective EMI reduction. When working with electrical systems, always follow safe work practices and use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. To energize circuits before working on them whenever possible. If you must work on energized circuits, use extreme caution and follow proper lockout/tagout procedures. Regularly inspect electrical equipment for signs of damage or wear. Repair or replace damaged equipment promptly to prevent electrical hazards. Keep electrical panels and equipment rooms clean and free of obstructions. Ensure adequate ventilation to prevent overheating. Train personnel on proper electrical safety procedures. Conduct regular safety audits to identify and correct potential hazards. Use appropriate test equipment to verify the voltage and current levels in electrical circuits. Never work alone on electrical systems. Have a qualified person present to assist you in case of an emergency. Be aware of the potential hazards associated with working near electrical equipment, such as electric shock, arc flash, and explosions. Follow all applicable safety regulations and guidelines. When selecting a transformer, consider the kVA rating, voltage ratio, impedance, and other relevant factors. Choose a transformer that is properly sized for the load it will be serving. Install transformers in a well-ventilated area to prevent overheating. Regularly inspect transformers for signs of damage or leaks. Maintain proper oil levels in oil-filled transformers. Keep transformers clean and free of dust and debris. Ensure that transformers are properly grounded. Use appropriate overcurrent protection devices to protect transformers from overload and short-circuit conditions. When installing panel boards, follow the manufacturer's instructions and all applicable electrical codes. Choose a panel board that is properly sized for the load it will be serving. Ensure that the panel board is properly grounded. Use appropriate circuit breakers or fuses to protect each circuit. Label each circuit clearly to indicate its purpose. Keep panel boards clean and free of obstructions. Regularly inspect panel boards for signs of damage or overheating. Tighten all connections to ensure good electrical contact. Use appropriate wire connectors and terminations. Follow proper wiring practices to ensure safe and reliable operation. When working with computer whips, use appropriate connectors and terminations. Ensure that all wires are properly identified and labeled. Follow proper grounding practices to minimize electrical noise. Use shielded cables to reduce electromagnetic interference. Avoid running computer whips near sources of electrical noise, such as motors and transformers. Use cable trays or other supports to keep computer whips organized and protected. Regularly inspect computer whips for signs of damage or wear. Replace damaged computer whips promptly to prevent electrical hazards. Follow all applicable electrical codes and regulations. Remember that electrical work should only be performed by qualified and licensed electricians. If you are not qualified to perform electrical work, consult a qualified electrician. Electrical systems can be dangerous, and it is important to take all necessary precautions to prevent accidents. Always prioritize safety when working with electrical equipment. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest advances in electrical technology and safety practices. It is important to stay up to date on the latest NEC requirements. Local electrical codes may also have additional requirements that must be followed. Always consult with local authorities to ensure compliance with all applicable codes. Electrical inspections are typically required for new electrical installations and renovations. Inspections are performed by qualified electrical inspectors to ensure that the work complies with all applicable codes and standards. Failure to comply with electrical codes can result in fines and other penalties. It is important to obtain all necessary permits before beginning any electrical work. Proper electrical design is essential for a safe and reliable electrical system. Electrical designers use their knowledge of electrical codes, standards, and best practices to create electrical designs that meet the needs of the building or facility. Electrical design should be reviewed by a qualified electrical engineer. Electrical drawings and specifications are used to communicate the electrical design to contractors and installers. Accurate and complete electrical drawings and specifications are essential for a successful electrical project. Electrical commissioning is the process of verifying that the electrical system is installed and operating correctly. Commissioning is typically performed by a qualified commissioning agent. Commissioning helps to identify and correct any problems with the electrical system before it is put into service. Electrical maintenance is essential for keeping the electrical system operating safely and reliably. Maintenance should be performed on a regular basis by qualified personnel. Maintenance activities include inspecting, testing, and cleaning electrical equipment. Proper electrical maintenance can help to prevent electrical failures and extend the life of electrical equipment. Electrical troubleshooting is the process of identifying and correcting problems with the electrical system. Troubleshooting requires a thorough understanding of electrical principles and systems. Troubleshooting should be performed by qualified personnel. The use of appropriate test equipment is essential for effective troubleshooting. Electrical safety training is essential for all personnel who work with or near electrical equipment. Training should cover the hazards of electricity, safe work practices, and the use of personal protective equipment. Regular refresher training is important to keep personnel up to date on the latest safety procedures. In summary, when sizing panel boards from a 75 kVA transformer, remember that the transformer can supply up to two 225 amp 42 circuit panel boards. The derived secondary conductors should originate and terminate as described previously. Identify the computer whip conductors correctly. Employ field quieting techniques such as shielded cables, load balancing, and harmonic filters. And utilize spell check tools to ensure accurate documentation. Adhering to these guidelines will help ensure a safe and efficient electrical system. Also, remember to consult with qualified electricians and engineers for specific applications and to ensure compliance with all applicable codes and regulations. It is important to understand the role of grounding and bonding in electrical systems. Grounding provides a path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock hazards. Bonding connects all metallic parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for electrical safety. There are different types of grounding systems, such as grounded, ungrounded, and impedance-grounded systems. The type of grounding system used depends on the application and the specific requirements of the electrical system. Each type of grounding system has its own advantages and disadvantages. The size of the grounding conductor is determined by the size of the service entrance conductors. The grounding conductor must be large enough to carry the fault current without overheating. The grounding conductor must be properly connected to the grounding electrode system. The grounding electrode system consists of one or more grounding electrodes, such as ground rods, ground plates, or underground metallic water pipes. The grounding electrode system must provide a low impedance path to ground. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning or other transient events. SPD divert the surge current to ground, preventing it from damaging sensitive electronic equipment. SPD should be installed at the service entrance and at branch panel boards. There are different types of SPD, such as metal oxide varistors, or MOVs, and silicon avalanche diodes, or SADs. The type of SPD used depends on the application and the level of protection required. It is important to properly ground the SPD to ensure effective surge protection. Power quality refers to the characteristics of the electrical power supply, such as voltage, frequency, and waveform. Poor power quality can cause problems with electrical equipment, such as malfunction, overheating, and premature failure. Common power quality problems include voltage sags, voltage swells, harmonics, and transients. Power quality can be improved by using power conditioning equipment, such as voltage regulators, harmonic filters, and surge suppressors. Power quality monitoring equipment can be used to identify and diagnose power quality problems. Energy efficiency is the practice of using less energy to perform the same task. Improving energy efficiency can save money on electricity bills and reduce greenhouse gas emissions. There are many ways to improve energy efficiency, such as using energy-efficient lighting, appliances, and equipment. Energy audits can be performed to identify areas where energy can be saved. Energy management systems can be used to monitor and control energy consumption. Renewable energy sources, such as solar, wind, and hydropower, can be used to generate electricity. Renewable energy sources are sustainable and do not produce greenhouse gas emissions. The cost of renewable energy has decreased significantly in recent years, making it a more viable option for many applications. Smart grids are electrical grids that use advanced technologies to improve efficiency, reliability, and security. Smart grids can monitor and control the flow of electricity in real time. Smart grids can integrate renewable energy sources more effectively. Smart grids can provide consumers with more information about their energy consumption. The future of electrical systems is likely to involve more renewable energy, smart grids, and energy-efficient technologies. Electrical engineers will play a key role in developing and implementing these new technologies. The field of electrical engineering is constantly evolving, so it is important to stay up to date on the latest advances. Continuing education and professional development are essential for electrical engineers. Professional organizations, such as the Institute of Electrical and Electronics Engineers or IEE, offer a variety of resources for electrical engineers, including conferences, publications, and training courses. Obtaining a professional engineering license can enhance career opportunities for electrical engineers. A professional engineering license demonstrates competence and commitment to ethical practice. Many jurisdictions require a professional engineering license to perform certain types of electrical engineering work. It is important to understand the legal and ethical responsibilities of electrical engineers. Electrical engineers must act in a responsible and ethical manner to protect the public health, safety, and welfare. The Code of Ethics for Electrical Engineers outlines the principles and standards of conduct for the profession. Violations of the Code of Ethics can result in disciplinary action. Electrical safety is a shared responsibility. Everyone who works with or near electrical equipment has a responsibility to follow safe work practices and prevent accident. By working together, we can create a safer electrical environment for everyone. Always prioritize safety and never take risks when working with electricity. Remember that electricity can be dangerous and it is important to respect its power. Always consult with qualified professionals for specific electrical applications and to ensure compliance with all applicable codes and regulations. It is crucial to stay informed about the latest developments in electrical technology and safety practices. Continuous learning is essential for maintaining competence and ensuring a safe and reliable electrical system. The proper selection and installation of electrical equipment are essential for ensuring safety and performance. Consider the specific requirements of the application when choosing electrical equipment. Follow the manufacturer's instructions and all applicable codes and standards when installing electrical equipment. Regular inspection and maintenance of electrical equipment are crucial for preventing failures and ensuring safety. Perform inspections on a regular basis to identify any signs of damage or wear. Repair or replace damaged equipment promptly to prevent electrical hazards. Keep electrical equipment clean and free of dust and debris. Ensure that all connections are tight and secure. Use appropriate test equipment to verify the proper operation of electrical equipment. Proper documentation of electrical systems is essential for troubleshooting and maintenance. Maintain accurate and up-to-date electrical drawings and specifications. Keep records of all inspections, tests, and maintenance activities. Document any changes or modifications made to the electrical system. Use a consistent and organized system for storing and retrieving electrical documentation. Effective communication is essential for successful electrical projects. Communicate clearly and effectively with all stakeholders, including engineers, contractors, and owners. Use appropriate communication tools and techniques to ensure that everyone is on the same page. Document all communications and decisions in writing. Respond promptly to inquiries and concerns. Follow up on outstanding issues to ensure resolution. A collaborative approach is essential for successful electrical projects. Work collaboratively with all stakeholders to achieve common goals. Share information and resources openly and honestly. Respect the opinions and perspectives of others. Resolve conflicts constructively and professionally. Embrace innovation and strive for continuous improvement in electrical systems. Stay informed about the latest technologies and best practices. Experiment with new ideas and approaches. Evaluate the results of your experiments and make adjustments as needed. Share your knowledge and experiences with others. Contribute to the advancement of the electrical engineering profession.